In the last section, we started talking about electrolytes. We said that an electrolyte was something that will conduct electricity when it's dissolved in water. We said that a strong electrolyte is something that conducts a lot of electricity because it breaks apart or ionizes completely in water. A weak electrolyte is going to only conduct a little bit of electricity because it only dissociates or breaks apart a little bit, okay? So strong acids and strong bases were good electrolytes. Weak acids and weak bases are going to be weak electrolytes. Now, before, when we were looking at acids, we saw HCl with the arrow to indicate that it broke completely into H plus and Cl minus. It ionized completely. Here I've got acetic acid, which is a weak acid, and instead of seeing a regular arrow, I see a two-sided arrow. This two-sided arrow shows the reaction goes both ways. What that tells me is that this doesn't completely break up into H plus and C2H3O2 minus. Some of it breaks up, but some of this stays as acetic acid. In fact, because it's a weak acid, most of it stays as the initial weak acid. Okay? So whenever we see a double arrow, it shows us that the reaction goes both ways, but it also tells us it does not go to completion. Okay? Non-electrolytes don't conduct electricity. They do dissolve in water, but they don't produce ions. Remember, it's the positive and negative charge of the ions that allow me to conduct electricity. So sugar, for example, dissolves in water. However, because sugar is a molecular compound, when it dissolves, I have molecules, not ions, and the molecules are not capable of conducting electricity. Okay? So we're actually going to be doing a lot of math with this chapter. And when we do our math, there are two things we need to know. We always need to know the forms and the types of chemicals that we have, so what the reaction is, and we need to know the concentration of our chemicals. Now, there are lots of different ways I can measure concentration. The most common, and the one that's going to be the most useful for us in this chapter, is molarity. Now, molarity is represented with a capital M. Oftentimes you'll see me write it as a capital M with a line underneath it, and that's my way of just showing that it's capital M, not lowercase m, and molarity versus meters versus molality, just to make things a little bit more clear for me. Okay? Now, molarity is the moles of solute, moles of the stuff that dissolved, per volume, and this is actually liters of solution in liters, so actually that already said that. So what it'll look like is it'll be moles of solute per divided by liters of solution. Okay? So here's the way that this would work. Okay? Calculate the molarity of a solution prepared by dissolving 11.5 grams of solid NaOH in enough water to make 1.50 liters of solution. Well, I want moles per liter. I have liters, but I don't have moles. So I need to, step one, change grams to moles. So 1.5 grams of NaOH, time sign, line. I want grams to go away, so grams go on the bottom. I want to change to moles. I know I find grams on the periodic table. Sodium weighs 23. Oxygen weighs 16. Hydrogen weighs 1. So 23 plus 16 plus 1 is 40. And the number on the periodic table is always equal to 1 mole. 11.5 divided by 40, I get 0.2875. I can only keep 3 sig figs, so 0.288 moles of NaOH divided by liters of solution. So when I plug this in, 0.288 divided by 1.55, I get that my molarity is 0.192, and we actually pronounce this as molar, so 0.192 molar NaOH, or 0.192 moles of NaOH per liter of solution. Okay? Take a second to solve example 2. The only thing you need to be cautious of in example 2 is that they give you your volume in milliliters. My molarity is moles of solute per liter of solution. Make sure before you solve you change your milliliters to liters. Okay. Now, when we talk about concentration, it's important to remember that we're talking about our solute before it dissolved. Okay? So here's what I mean before it dissolved. I've got cobalt 2 nitrate dissolving in water. I dissolved enough cobalt 2 nitrate to get a 0.50 molar solution. Now, cobalt 2 nitrate, when it dissolves into water, breaks into cobalt with a +2 charge and 2 NO3 negative ions, 2 nitrate ions. So if I was looking at the concentration of each ion, for every 1 mole of cobalt nitrate, I get 1 mole of cobalt +2. So since I have a 0.50 molar solution, I would have 0.50 molar cobalt with a +2. However, because for every 1 mole of these I make, I have 2 moles of these, I would have, instead of 0.5, it would be 0.5 times 2. So I would have 1.0 molar NO3 negative. Okay? So when we're talking about it in terms of ions, the ions, you have to multiply the molarity by the number of ions present in solution. Okay? So take a second. I have 1 molar iron 3 hypochlorite. Take a second and figure out, perchlorate. Take a second and figure out what the concentration is of your iron 3 ions and what your concentration is of your perchlorate ions. So remember, molarity is concentration, moles of solute per liter of solution. We're going to use molarity so often, it's very important that you remember what it is and how to use it.